Okay, let's hope this is the final clarification on problem 3. So just quickly starting at the very beginning, if you want to know f prime of x, this is the general formula for computing f prime of x from first principles, let's say, from the theory of limits. Okay, so far so good. And just to have a concrete example in mind, let's just take a simple function, f of x equals x squared. Of course, we could say y equals f of x equals x squared. And then we now know automatically that f prime of x equals 2x, but again, if you had to prove it, you go back to the original formula, and you would get the limit as h approaches 0 of x plus h squared minus x squared over h, and you expand that out, and you get x squared plus 2h x plus h squared, plus h squared minus x squared over h, and that equals, you have an x squared minus x squared, so you have 2hx plus h squared over h, and you can divide out by h, and you get 2x plus h, but as h goes to 0, this goes to 2x. Okay, just review. Let's now look at, and so now if you want to find f prime of 2, you just plug in and you get 4. Okay. Now, getting back to problem 3, here's where I had a little trouble explaining this properly. So again, this is just our example to keep in the back of our head as an example. But in problem C, they are expressing different ways. There's different expressions for f prime at 2 or f prime of 2. So we have, on the one hand, limit as h approaches 0 of f of 2 plus h approaches 0 minus f of 2 all over h. And then there's another expression, limit as x approaches 2 of f of x minus f of 2 all over x minus 2. Okay, and one thing that is correct is that these are equivalent expressions for f prime of 2. Okay, they both say the same thing, but there is a difference. This one does not allow you to actually calculate the limit from first principle, calculate the derivative from first principles, so to speak. You have to go to this form, an equivalent expression, but you have to use this form to actually calculate the derivative. And the proof is, going back to this example, we could put in the limit as h approaches 0 of f plus 2h squared minus 2 squared over h. And it really is the same computation as on the previous page. You wind up with 4 minus 4 minus for h, 4 plus 4h 4 plus 4h plus h squared minus 4 all over h, and the 4's subtract out, you're left with 4h over h plus h squared. Divide through by h, and you get 4 plus h, but as h goes to 0, this goes to 4. So you do arrive at f prime of 2 correctly, but you're not able to do it with this expression even though it is equivalent. Okay, I hope that's clear.